This talk's going to break down into three parts. The first part, which is from a technical point of view, how we could be able to get to Mars in the near future. That's one of the sunnier parts. The second part is the more dark part, which is how do we try to make this happen in the current world. And then finally, the third part, which is also a sunny part, which is what can we create once we are there. Okay, so I'm going to start where we are now, which is a situation that has significant promise, but also, as we'll discuss, great difficulties. Okay. One thing, of course, that offers great promise right now is the rapid development of the Starship. It is moving along. It's taken, as most of us expected, rather longer than Musk predicted it would take, but it is happening. And I think it would be, it's had a lot of failures. That's part of SpaceX's methodology: launch, crash, fix what went wrong, try to get a little further into the flight envelope, etc. And they're now pretty close to establishing the ability to have it get to orbit. Now, well, first, let me put that aside. Okay. A number of years ago, as I think everyone here knows, proposed a mission plan for humans to Mars, which is called the Mars Direct Plan. And if you haven't read about it, you can read about it either in my book in English, which you can get on Amazon, or the French translation, which is available right over there. And in brief, the way that mission plan would work is you use a heavy lift vehicle to lift to Earth orbit. First, an Earth return vehicle, which is then sent to Mars on trans-Mars injection using chemical propulsion. It lands there 8 months later, and in my scenario, it would bring with it the hydrogen needed to combine with Martian CO2 to fuel it up with methane oxygen bipropellant. And then when that is done, at the next opportunity, you have another heavy lift vehicle, and it shoots out to Mars a habitat module, which goes and lands near the Earth return vehicle and makes camp there. You use that as your base for a year and a half on Mars, and at the end of that time, you get in the Earth return vehicle, you fly back to Earth, leaving your hab behind on Mars. And if you continue to do this, you can either create a string of bases on Mars or build up one location into a major base. There's various ways you can play this. That's the Mars Direct Plan in brief. So it was direct flight to Mars, no need for on-orbit assembly, no need for advanced propulsion, and in its original form, no orbit rendezvous of any kind. Just direct to Mars, direct return using in situ propellant, methane oxygen. Now, this idea was adopted in significant degree by Elon Musk as the basis of his plan for going to Mars with the Starship. The difference is that in his plan, the Starship would go to Earth orbit, where it would be refueled with methane oxygen bipropellant, allowing it to fly to Mars, and then then it would be used as your base on Mars, and it would be fueled with methane oxygen bipropellant made on Mars using water from Mars, mined from Martian ice, combined with CO2 to make the methane oxygen. By the time that Musk got into the game, we knew that, which we did not know at the time I wrote Mars Direct, that there was copious water available on Mars at mid-latitudes. There are Martian glaciers of pure water ice extending as far south as 38 degrees north, which is the latitude of Athens here on Earth. So ice is not limited to the pole on Mars. It is available at mid-latitudes. So we don't need to bring the hydrogen. But he would come back with a whole Starship, which weighs 100 tons, And so he would need like 600 tons of propellant made on Mars to bring that back instead of 100 tons, which is what we needed in Mars Direct. And thus, a much larger power source would be required to do the propellant manufacture. Now, so those are those two plans laid out in brief. The Mars Direct also had the advantage that the HAB module, which would be sent to Mars using an upper stage to throw it to Mars, you could tether the HAB module off the upper stage and spin it up, create artificial gravity, and thus avoid all the medical effects that were identified by the speaker earlier this morning of the zero gravity harm to the physiology of the astronauts. Although it must be said that the 6-month transit to Mars is equivalent to a 6-month stay on the space station, and people certainly survive that, although they are weakened by it. And so you could go to Mars in zero gravity. I don't think that's the best way to do it, but nevertheless, you can do it. Now, okay, so those are two ways to send humans to Mars. Now, there's this program right now, which you may have heard of, called Artemis. And it is a total mess. Okay? Artemis is nuts. Okay? I mean, this is no way to put it. The Artemis program, which is supposed to return astronauts to the moon and create a sustained presence on the moon, is composed of 5 major flight vehicle elements, which, however, do not fit together and do not create any capability between them. These flight elements are the Starship, the SLS heavy lift booster, the Orion capsule, the National Lander, which is an expendable 2-stage hydrogen-oxygen lander, and the Lunar Orbit Gateway. So these 5 separate programs. And they really have nothing to do with each other. They were all created independently and are supported independently by various constituencies, including, of course, the vendors who have these contracts and are getting funded through them, and therefore the congressional districts associated with them and various congressmen that are associated with those districts. So this is very different, for instance, from the Apollo moon program. In the Apollo moon program, we had a presidential directive: you need to get to the moon before this decade is out. NASA went off and developed a plan on how to do that. That plan then described a set of vehicles necessary to implement that plan. Contracts were then given out to develop those vehicles, and then the mission was flown. So it's a completely different point of view. It's the difference between you decide to build a house, you hire an architecture to design the house, and then you have a construction company build it to plan, as opposed to you travel around and you buy miscellaneous house parts from garage sales and you accumulate them into your backyard and then try to figure out how to build a house out of that. Okay, those are the two differences. And that is why the Artemis plan, Artemis was initiated 8 years ago in 2016. Okay? 8 years is the time between Kennedy's speech announcing the moon program and the moon landing, 1961 to 1969. It's been 8 years since this program was announced, and we have vastly more technological capabilities than they had, and the moon landing is nowhere in sight. Okay? Because Apollo was a purpose-driven program. Artemis is a vendor-driven program. Apollo spent money to do things. Artemis does things in order to spend money. Okay, that is the distinction. Okay, right there. Okay, now, so Artemis is a mess. Now, there is one part of Artemis which is coherent in itself, which is, although this is not the, well, it's sort of strange, but anyway, the Starship. Okay, in principle, you could do the whole lunar mission with Starship, and this is how Elon Musk would prefer to do it, which is you launch a Starship to Earth orbit. Okay, you then refuel it with, depending upon the actual performance achieved by the Starship and the payload you're carrying, between 3 and 6 tankers, okay, brought to Earth orbit. Okay, and that enables you to fly to the gateway. We'll say 4 tankers. And so now you have a Starship at the gateway, but it has no propellant. So now you need to send at least 3 more tankers to the gateway with propellant for the Starship. Each of them requires at least 3 more tankers to get them to the gateway. Okay, so now you have 16 launches, actually 17, launches to get a fueled Starship to the gateway that can then go down to the lunar surface, and if it doesn't dig itself into a crater by its big engines, it can take off and come back. But this is a very unwieldy plan, because this, by the way, assumes not only that Starship works, which I think it will, but that you can refuel it, and the performance actually achieved by the Starship is what Musk currently claims it will be. That is, it will only weigh 100 tons, and it will be able to transport 100 tons to Earth orbit. If, for example, it were to come in at 150 tons and therefore only be able to bring 50 tons to Earth orbit, instead of 17 launches per lunar mission, you would need more like 40. Okay, so this is not a practical architecture. Okay, this is just nonsense. The answer for this, there's a number of answers for it, but the most obvious answer is you don't bring the Starship to the lunar surface. Okay, you could, for example, just bring it to low lunar orbit and then use a much smaller methane oxygen powered vehicle, what I call the star boat, to go from lunar orbit to the lunar surface and back up again. And the star boat would be something kind of like Starship, but a factor of 5 to 10 smaller, okay, depending upon what you're asking of it. Now, this could also be used for Mars, because instead of sending the Starship all the way to the Martian surface, you could position it in low Mars orbit, and the delta V to go from the lunar surface, the lunar orbit to the surface and back up again is 4 kilometers a second, 2 down, 2 up. The delta V to go from low Mars orbit to the Mars surface and back again is 4 kilometers a surface, almost nothing going down, and 4 kilometers a second coming up. Okay, so the same star boat that could do ferrying activity between low lunar orbit and the lunar surface and back up could also do low Mars orbit to the Martian surface and back up again. Okay, now you can say, well, gee, the Mars one will need thermal protection, the lunar one won't, and you could specialize it further, and that would give you an even better performance. But frankly, if you just took the Mars vehicle and used it to do the moon, you'd get, 80 to 90% of the benefit that you get from having 3 different vehicles instead of 2. So Musk wants one size fits all, doesn't work. 2 size fits all does work. 3 would make it work a little better, but all you need is 2. Okay, 2 does the job here. Now, that is the corrective. There's some other variants you could do. If you want to go with a slightly larger star boat, instead of a factor of 10 smaller than Starship, it's a factor of 5 smaller than Starship. So instead of weighing 100 tons, it weighs 20. Okay, the amount of propellant it would need to go to Mars is about 80 tons. So you could lift it to low Earth orbit in a Starship, if the Starship can deliver 100 tons to low Earth orbit, and simply have it shoot itself off to Mars, and you would not need orbital refueling at all. Okay, that is another variant to do this. Now, I explained all this to Musk in 2020, and he blew me off. He basically said, look, I only want to develop one vehicle. We're going to do it my way. This is how it is. Now, there was a possible corrective to that, because Musk got the contract for the human landing system for the moon using Starship in the way that I just described. And the competition, which was known as the national team, composed of Blue Origin, Lockheed Martin, and some other companies, they started yelling and screaming that they needed to get a contract too, and if they didn't get it, they'd hate NASA forever, and they have a lot of friends in Congress, and so you better give us a contract. And their congressional friends told NASA, you better give them a contract, so they gave them a contract. So can't blame NASA for that. Hand was forced on giving the NASA national team a contract. But the problem is what they should have done was given them a contract for something like Starboat. Okay? That is, they said, sure, you want money, we'll give you money, but this is what we need: a single stage methane oxygen vehicle that can do 4 kilometers a second. Instead, they just gave them a contract for whatever Lockheed Martin and Blue wanted to do, which was this 2-stage hydrogen oxygen lander, which cannot be fueled from Starship. They're incompatible. That is, the number one requirement on the national lander was that the national team gets money. They filled that. But they didn't fill the number 2 requirement, which is that it be useful. So this, and NASA can't be blamed for that. So that is where things stand right now. That is, there is this Artemis program, okay, which has a lot of money to throw around, and a supposed national imperative to get humans to the moon before the Chinese do. And also Trump, of course, announced in his inaugural address, I'm sending humans to Mars by the end of my term. Okay, now, there's 2 problems with that statement. Okay, one is that it's not true, and the other is that the person making it doesn't care whether it's true or not. Okay, and actually the second problem is bigger. But you see, okay. Jared Isaacman, who's a good person, and he was nominated by Elon Musk to be NASA administrator early in the Trump administration. But Musk went and irritated everybody in the Trump White House, even though he had given Trump $200 million to get him elected. Musk has become irritating because he thinks he's a god, and it bothers people when they talk to him. And so he got thrown out of the White House, and then to further the decisiveness of that expulsion, they also denominated Jared Isaacman from NASA administrator. Okay, so NASA has gone for the past 10 months or so without an administrator at all. And meantime, there was this crew known as the Department of Government Efficiency, or DOGE, who went through NASA with a wrecking operation directed primarily against the space science program, which includes the Mars exploration program, all the Mars rovers and orbiters and all that, as well as the space telescopes, as well as the outer solar system probes, and all that. Basically, actually, the productive part of NASA. That is, all the real accomplishments of NASA since the end of the Apollo program have been done by the Space Science Directorate. And it's certainly not a perfect organization. There's a number of things it has done that I would differ with. But nevertheless, it has been, like Apollo was, a purpose-driven organization. The Space Science Directorate spends money to do things. They do not do things to spend money. Okay, and so this has been essentially proposed for destruction, 50% cut, including not only Mars sample return, but even shutting down 2 orbiters, the Mars Odyssey orbiter and the Maven orbiter, that are currently in orbit around Mars right now, operating. They want to, and not only shut them down, but deorbit them so that they cannot be restarted. I'm not making this up, okay? and also the Juno probe in orbit around Jupiter, and a whole bunch of spacecraft doing Earth observation sciences. That is, these are not good people. So they've been allowed to run riot. Now, Isaacman has now been reproposed to be NASA administrator, and in fact, the hearing is going to be next week, and I believe he'll be confirmed. Many of Trump's cabinet nominees have been extremely unqualified, and they got confirmed anyway. Isaacman actually is qualified, and I think he'll be confirmed even with a certain amount of bipartisan support. But what the problem is for him to do anything, he will need to go in there and say, look, this is all bullshit. I have to change everything. Okay? That's a hard thing to do. Okay? That's going to be hard to go down with the Trumpists themselves. Trump put Artemis into action in 2017, actually, during the first year of his first administration. And the design philosophy was, we can get a lot of support for this program if we throw money in all directions, because everybody getting money will like us. And that is basically how Artemis was launched. And instead, but that you can't actually get to the moon that way. Okay, you can get support for your program that way, no doubt. But you can't actually get to the moon by spending randomly. You have to spend with purpose. And that means most of Artemis has to go away. So whether or not he can do that is a big question. There's also other questions here. Okay, the decision by the DOGE, the Trump administration, to wreck the space science program is incompatible with the long-term prospects of their Mars program. Okay, it is not true that Trump is going to be able to land humans on Mars in 2028 during his last year in office. This is going to take significantly longer than that. And that means that this program has to be put on a political foundation that will allow it to last long enough to succeed. Using this program as the justification for destroying the space science program, which is what they're doing. So we don't need to do Mars sample return. We don't need to do any other Mars probes because we're just going to send people. Makes enemies. And in particular, okay, in other words, they need bipartisan support. Okay, the space science program has significant Democrat support because it is university-based, and the university professors tend to lean left. And so they have excellent connections with the Democratic Party. And if you wanted to have bipartisan support for the Mars program, the last thing you want to do is take an extreme partisan position and say, we're wrecking all the stuff in the Mars program that the Democrats like. Okay, you want to do the exact opposite. What you want to do, what you should do, is say, look, we're developing capacities to land heavy payloads on Mars. And the same Mars lander that can land, okay, Musk says he can land 100 tons on Mars. Let's say it can really land 30. 30 tons. That's a lot more than the current Perseverance lander, which can land 1. Okay, so gee, if you have a lander that can land 30 tons on Mars, what's the best way to test that? Land a robotic expedition on Mars. Instead of sending 1 rover to Mars, send, 30 and 30 helicopters and a well-equipped science lab in the lander that the rovers and helicopters can bring samples back to. And you'd have just a gigantic scientific bonanza here. And so you'd have, 60 different flight vehicles as well as a lab, and each of them has got 5 different instruments on it. So maybe you got 100 different instruments being flown to Mars, and you've got 100 university teams backing these instruments, or some of these instruments will be backed by 4 or 5 universities. You say you got 300 university teams, engaged in the mission, okay, and you have massive political support, and not just because you're throwing money around, but because you're doing amazing science. Amazing science. And so you're saying humans to Mars is not the enemy of science, it's the best friend science ever had. Okay? That's how you do this program if you want it to succeed. Now, whether Isaacman has the guts and the fortitude and the ability to change directions to make that happen is unclear. Okay, but that's what needs to be done with respect to that. Now, I mean, look, some of the decisions that Doge made are arguably supportable. Okay, I believe Mars sample return had kind of lost the plot, and it been turned into a $10 billion mission that would take a decade and a half to do. I think, given that it had gone that way, there's a good argument for canceling it, but not for just canceling it, but taking that $10 billion and doing 20 missions with an average cost each of $500 million. Okay, that's a different way to explore Mars than a $10 billion sample return, and there's a lot of merit in that proposal, but that is not what they proposed. They just said, we're killing this. Okay, we're killing that, and we're killing this and the other thing. Okay, and so they didn't, they used elements of irrationality within the existing space science program as an excuse to destroy the program, as opposed to, okay, this is how we're going to correct this. Okay, so that's a problem. They no. So, yes, I mean, I think if we're doing a Humans to Mars program and we're developing vastly superior capabilities for delivering payloads to Mars and to the Martian surface, this could be and should be exploited by the science program, not being used as a pretext to destroy the Mars science program. Okay. So there it is. That is that situation, and we can discuss it more in the questions. But now, for the, if we can get past this, let's now somehow get past this, what can we create on Mars? If it really does come to pass that capabilities are developed for sending humans to Mars, and I think, I mean, I have a lot of difficulties with Musk. I actually know him personally, and we have parted ways on Ukraine and other things. But it nevertheless is true that he and his team have accomplished amazing things. Essentially, three things. One is they've actually introduced various flight systems that offer terrific capability, such as the Falcon 9. They managed to launch over 100 of them last year. That's 2 per week, okay, with the same capability as the Ariane 5, 20 tons to orbit. This is just amazing, okay? And I believe they will make Starship successful sooner or later. Second is they have proven a broader point, which is that it is possible for a well-led entrepreneurial team to do things that it was previously thought that only the governments of major powers could do. And not only that, do them in 1/3 the time at 1/10 the cost. And even do things that were deemed just not possible at all, such as, of course, reusable launch vehicles. So this has changed the paradigm. Okay, and there's a third thing, but I forget what it is. Anyway, those two are important enough. And let me see what I can do about this. Hold on. All right. Now, here's the thing. Falcon 9 is an unquestionable success. And as a result, there's now 5 companies in China who have gotten investors who are trying to make a knockoff of the Falcon 9. Okay? And also a couple in the free world. If Starship is successful, there will be plenty of people making their own versions of Starships. Okay? So it will become a generic thing. It will not depend upon the particular business model of Elon Musk. There'll be a variety of Starship kind of vehicles, reusable vehicles, and reusable heavy lift vehicles, or what we now call heavy lift vehicles, but will probably be viewed in the future as medium lift vehicles. But in any case, so now here's the thing. the introduction of reusable vehicles, and I guess that was the third point about Musk and so forth, means there is soon going to be something else in the world that hasn't existed before, which is a market in used launch vehicles. Think about that for a minute. Okay, there's an awful lot of people on this planet who own cars who could not possibly afford a new car. They own cars because they could buy a used car at 1/10 the cost that is nevertheless fully functional. Okay, so Musk told me that he could actually build the Starship, that is the upper stage, the part that goes to space, for $10 million, which means that either he or one of these emulators at some point would probably be willing to sell them for $20 million new, which means that at some point in the future, such things will be available used for $2 million. So let's say now we're moving ahead 30 years in the future. There's already been a number of expeditions to Mars, and people have figured out the basic life support and so forth needed to survive on Mars, and certain other Mars-relevant technologies have all been developed. And now there's this market in which you can pick up a used Starship or Starship equivalent vehicle for $2 million. Well, this thing is supposed to be able to transport 100 people to Mars. $2 million divided by 100 people is $20,000 a person. Now, $20,000, I have never bought an airplane ticket for $20,000, and I hope I will never have to do that. But compared to the cost to, say, emigrate to America in the 17 or 1800s, okay, that is, that number compared to income, okay, is actually much smaller. Okay, that is, 30-40% of the average salary of a working man. Okay, the cost of going to America in the 1800s or even the early 20th century was a lot more than that as a percentage of a worker's average salary. In fact, in the colonial period, coming to America, if you were a person without property and you had to get it paid for you, you'd mortgage 7 years' work. Okay, literally, that was done quite commonly. So this is cheap. So what this is saying is that if you had a group of people that wanted to establish their own colony on Mars, they could put together the funds to do it. And so I do not believe that when we get around to settling Mars, there's going to be one giant million-person Mars city, as Musk has proposed. I think there's going to be a multitude of smaller settlements. And the ones that grow into cities, perhaps we're talking about getting to 50,000 people cities. I mean, 50,000 persons is the population of Renaissance Florence, okay, or Amsterdam. It is a population that can support a culture, a creative culture. And it's a much more reasonable proposition than a million. Million-person cities were quite rare on Earth until there were railroads, because to have a million-person city involves transporting very large quantities of materials from long distances to one central point. Okay, and it's going to be a while before you have railroads on Mars. So small settlements, 10,000 people, maybe get to 50,000 people. Now, these settlements will be launched by a variety of people with very different ideals as to what the ideal society should be. People ask me, what's the Martian government going to be? Okay? And the answer is there's going to be a lot of different ideas. There's going to be experiments, noble experiments. Founders of the United States called our Constitution a noble experiment. Okay, it worked well enough that millions of people decided to vote with their feet to come to America, and we grew. And we outgrew a lot of other places in the Americas that had different experiments. And in fact, within the United States, there were 2 experiments done. Okay, and this is an important point. Okay, because the northern United States and the southern United States were two very different societies. Okay, the North, okay, both were suffered from the same problem, which was a labor shortage. We had a terrific labor shortage in the New World during the colonial and period in the 19th century. Okay, two different sections resolved it in opposite ways. In the North, it was resolved through labor-saving technology. Okay, and Americans became impresarios at labor-saving gadgeteering. This became a cultural trait. It's an American stereotype, the backyard inventor, and it's one with significant reality behind it. Okay, so labor-saving technology, this is actually labor productivity multiplying technology. And this leads to high pay because the average amount of product available per person on average equals the average product produced per person. Okay, and so if you're multiplying the power of labor through technology, you are going to raise the average pay rate, which then, of course, becomes a terrific incentive for example, Europeans and Asians to come to America. Okay, in the South, this problem was resolved in an entirely different way, which is through slavery. Okay, and in the United States, there's a lot of people who are fascinated with the American Civil War buffs, they're called. And and if you ask any Civil War buff, why did the North win the Civil War? They will answer correctly, because it had a much larger population and more industry. Okay, but why did it have a larger population and more industry? Because it was free. All the immigrants, almost all, went to the North, not to the South. And, during our Civil War, the Northern Army, the Union Army, was 40% immigrants or first-generation Americans. Confederates, the Southerners, 3%. Okay, that's the difference. That decided it right there. So here's the point. Okay, liberty prevailed in America because that's where the immigrants went. I believe that the same will be true on Mars. I believe that, the science fiction novel, which is very popular format of the extraterrestrial tyranny, and I love novels like this. You have the heroic revolutionaries battling the fascistic tyrants, and you're off to the races in terms of the plot. But I don't think this is realistic at all, because any extraterrestrial tyranny would die on the vine, because no one would want to emigrate to it. Okay? So I believe that while people will go to Mars with all sorts of models as to what the society should be, I believe that the model that will prevail is the one that will attract the most immigrants. And that includes freedom. That includes maximizing the potential for human beings to realize their full human potential. That is where people will go. That is why freedom will prevail on Mars. Now, another science fiction trope, for instance, in Total Recall, is the Mars colony as a total dump. Okay? I don't think that is going to work either. Okay? Because it will make them less desirable for immigrants, and in particular, women immigrants who have aesthetic standards that would not meet. The reason why I'm talking to you in English right now instead of French is because British women were willing to go to North America, because the British colonies in North America built complete communities with schools and churches and all these things. Okay, the French colonies in North America, and France had 4 times the population of England during the period in which they were contesting for North America. These were organized as commercial trading posts, making money on the beaver trade, and French women were not willing to go to North America. Okay, and so by the time the decisive conflict came in the 1750s, there were 2 million English-speaking people in North America and 50,000 French. Okay, so the Mars colonies that will prevail, once again, those that are the most attractive to immigrants will be those that are aesthetically attractive. Cities need to be both functional and beautiful. 5 minutes. I have 5 minutes left.
4, in fact.
4? We started at 10 after. Okay. Okay. But basically, I could go on, but what I'm saying is that the Mars colonies that will prevail will be those that are free, that have vibrant cultural lives, that have all these things that draw immigrants to them. Okay, and one could discuss what their product will be. There's a number of things, but one of the most important will be invention, because the Mars colonies will be a group of people, largely technologically adept people in a frontier environment that forces them to innovate, and therefore they will innovate in a whole range of areas, including food production, because they'll have extremely limited acreage in greenhouse agriculture, or energy, where there's no fossil fuels on Mars, and solar is very weak, and wind is weak, and so forth, and it won't be water power until the planet's terraformed. So, although there'll be a lot then, but so there'll be innovators in nuclear power and fusion power. Deuterium is 5 times as common on Mars as it is on Earth. They're going to want to do that. But the sorts of innovations that they make will make their lives possible, but they will greatly advance the human condition overall. Okay, Musk, and this is another disagreement I have with Musk, he says that the reason for his Mars colony, which he calls Terminus, after the colony in the Isaac Asimov Foundation series, is so that there'll be a place where civilization will survive after the Earth is destroyed. I think this is A, nonsensical, and B, morally repugnant. We're not going to Mars to desert the Earth. And frankly, there's no way a Martian colony could survive as an autarky. We do want to make as many things on Mars as we can, but there'll always be a need for trade with the Earth, especially to acquire goods that require a very high division of labor to produce. I mean, it's one thing to produce. Yes, we're going to produce propellant on Mars, but producing this is a much more complicated kind of thing to do. And they're going to need this, or things like that. And so it's wrong. We're not going to Mars to escape from a destroying Earth. We're going to Mars to expand the creative capacity of the human race, to add another inventive branch of human society to the human race as a whole. Okay, so it's going to be together to Mars, and then together with Mars, we're going to take on the future. I'm going to leave it there.
Okay, a few questions, please.
Yeah, so you said like the Apollo was a purpose-driven organization as opposed to the Artemis. Now, is there like something you can say about China in this approach? Because you always hear this a little bit, because China is very quiet about its program and what's going on, but it seems that they're like really, they're having the timeline, they're on time, no delays, what they're doing.
There is a speaker. The next speaker is going to talk about China's program.
All right, but China appears to be moving ahead in a very deliberate, purpose-driven way. So unless there's radical reform in Artemis, China will absolutely beat NASA to establishing an effective presence on the moon.
You presented a way that seemed very sensible regarding how to restart, let's say, the Mars program and science program in the right track. To your knowledge, has Jared Isaacman heard about that vision of a thing?
Well, he has, because I spoke to him.
Okay.
Okay, so, but we'll see what he does and what he's capable of doing. I can remember a conversation I had with Mike Griffin about a variety of other issues when he was NASA administrator, and I said, look, here's what you have to do, this. He says, you're right, but you don't understand the constraints that I'm operating under, okay? And so none of what I told him was done. But but that's a different story. But yes, he is aware. Other questions? No other questions. So I've answered everyone's questions. Okay, there's one more question.
Hello, Dr. Zubrin. Congrats for your presentation. From a technical perspective, go to Mars is a very long trip. Do you think that it could be, sorry, I don't find the English word, but it would be better to have a relevant propulsion to reduce time of the trip?
No. I don't.
I speak about the human factor.
Oh, yes, but I'm going to answer you. Okay. The correct orbit to go to Mars is a 6-month trajectory. And the reason why is because this is the trajectory that if you decide not to go to Mars, you will loop out to about 2 astronomical units and you will come back to 1 AU, the Earth's distance from the Sun, exactly 1 year after you left. And so the Earth will be there. If I've got nothing against superior propulsion systems, but let's say I had one, like a nuclear thermal rocket that has twice the specific impulse of a chemical rocket, okay, I would not use it to try to go to Mars faster. I would use it to double the payload.
Last question, please. Yeah.
Well, okay, you, sir. Go ahead. Yes, proceed.
What's your opinion on Mars cyclists or
Cyclers?
cyclists that stay in
Well, you could put, for instance, a starship in a cycling orbit between Earth and Mars, and then with the starboats go and try to intercept it at each end. And this would significantly reduce the propulsion requirements of going back and forth between Earth and Mars. There's an operational issue here of you're doing what's known as a hyperbolic rendezvous, where unlike in Earth orbit, where if you don't, you can rendezvous and then you can fiddle with it and get it right. If it's going by on an interplanetary trajectory, you've got one try to get this right. So it's entirely possible to do, but depending upon that would require gaining a lot of confidence in our ability to do these kind of all or nothing rendezvous maneuvers.
Last question?
Yeah.
The very last.
Last question. You mentioned that instead of producing Artemis program with a cost of $10 billion or something like that, it would be better to produce 20 missions, each of $500 million of dollars. Could you mention some of the focus of this mission that could be? Because in this sense, from the point of view of European industry, it could be far better to put together stuff to make $500 million Mars missions.
This is really an excellent question, and I'm glad you brought it up, and I'm not kidding. Because these sorts of missions are fully within the capability not just of ESA, but of major individual European players like France or Italy or the UK. And there's any number of such missions that could be desired. Okay, these include rover missions to lots of different places, helicopter missions to lots of different places, life detection experiments. We haven't put a life detection experiment on Mars since 1976, okay, which is just a little more, less than 50 years ago, okay? And it's a long time, actually. And so and there's need for this. And there's need for more than one life detection experiment because Mars is a big place. Mars has got a surface area equal to all the continents of the Earth put together. And there's many different kinds of life detection experiments I'd like to land on Mars. Okay, so, and then there's other things. There's ground penetrating radar, which would be a great platform to put on a helicopter, for example, because that's got long distance mobility but close to the ground. And the radar return signal strength goes as the inverse fourth power of the distance, inverse square down, inverse square back. So you're much better off doing ground penetrating radar from an aircraft than from an orbiter. and also the precision that you would accomplish is much greater. So there's a whole raft of missions that I'd like to do on Mars, and these missions could also be done on a much tighter schedule than the 15-year Mars sample return timeline, and the risk associated with 20 missions, each of which are independent of each other. Okay, so 3 fail, you still have 17 successes. Whereas you have a Mars sample return, which is currently conceived, requires 3 spacecraft, and if any one of the 3 fail, you lose the whole mission. I believe, I mean, look, somebody's got to use their brains. Okay, why not Europe? I think that, yes, you should see what you can get ESA to do, and you're doing the Rosalind Franklin thing. But I believe that there is absolutely room and necessity, I should add, for countries like France and Italy and the UK and Germany and Poland. I mean, the UAE did a Mars orbiter. Okay, and the UAE isn't even a real country. It's more of a gentleman's agreement. Okay, if they can do a Mars orbiter, so can Italy. Okay, and some of these orbiters, like the Mars Global Surveyor, was a $150 million mission. That's what it cost to build a nice shopping mall. So I think it is a mistake for Europe to say we have to do everything all together. I think it's good to do some things all together, but there'd be you could move much faster and with much greater creativity if you also do things individually. I know, for instance, a while back, okay, I guess Jacques Plumont probably isn't around anymore, but he was a very prominent French, he was an advocate of balloon exploration of Mars. And of course, France has got the honor of having introduced the balloon to the Earth. Well, put aside China, they don't count, but in the West. Yeah, France could do a Mars balloon mission. Okay, it's quite beneficial to have multiple centers of creative initiative. Okay, that not everything has to be decided upon by consensus, because if you have to have everything decided on by broad consensus, you don't really get anything really creative. Okay, now you might be able to get something that is good, but I think there's a lot more potential creativity in space exploration possible from Europe in particular if it says we'll do some things together, but France is going to do its own Mars mission. Italy is Germany, UK, okay, etc. Because you certainly can. Thank you.